Problem number 51. A string of violin is a little too tightly stretched. Beats at 4 per second are heard when the string is sounded together with a tuning fork that is oscillating accurately at constant E, 440 Hz. What is the period of violin string oscillating? And we know that beat frequency equals the difference between the frequencies of two devices. In our case, one device is violin and another is tuning fork. A string that is too tightly stretched has the higher tension and thus the higher fundamental frequency. So we can write that difference of frequency between violin and frequency of tuning fork is equal to beat frequency. So now write the data. Beat frequency is equal to 4 beats per second, and FT, frequency of tuning fork, is 440 Hz. And we also know that frequency of violin is related to time period by this equation. So now we can solve this time period. So we can put all data in this equation. 1 upon T minus 440 equal to beat frequency 4. 1 upon T equal to, if you move this here, this minus 440 will become plus 440. So 444. And time period is equal to 1 upon 444. And if we solve this, then time period is equal to 2.25 times 10 to power minus 3 seconds. So this is the answer. So this is the period of violin string oscillation. Problem number 52. A tuning fork of unknown frequency makes 3 beats per second with a standard fork of frequency 384 Hz. The beat frequency decreases when a small piece of wax is put on a prong of the first fork. What is the frequency of this fork? We know that beat frequency is equal to the difference between frequencies of two tuning forks. That is, beat frequency is equal to F2 minus F1, where F1 and F2 are the frequencies of two tuning forks. So we can say that this beat frequency is given 3 beats per second. So this mod, we don't know that which tuning fork has higher frequency, but the difference must be equal to 3 beats per second. So it means that F2 minus F1 or F1 minus F2, the mod, is equal to 3. So we have two fork like this. Okay, this is first fork, this is the second fork. So if you put wax on this fork, means you are increasing the mass, and we know that frequency is inversely proportional to the square root of mass. If you increase the mass, the frequency will decrease. So it means that beat frequency will also decrease. If we want to find the frequency of first fork, then it means F1 is equal to 3. You can move this here, this will become plus. So 3 plus the standard frequency of this fork is given, which is 384. So this will become 387. It means that frequency of first fork will be 384 Hertz. So this is the answer. Problem number 53. Two identical piano wires have a fundamental frequency of 600 Hz when kept under the same tension. What fractional increase in the tension of one wire will lead to the occurrence of 6 beats per second when both wires oscillate simultaneously? Let us suppose we have two wires. The frequency in first wire is F1 and second wire is F2. The tension in the first wire is T and tension in another wire is slightly changed, which is equal to T plus delta T. So let us write the data. F1 is 600, which is a fundamental frequency, and F2 must be 606 because beat frequency is 6 beats per second, and we know that beat frequency is equal to F1 minus F2, so F2 must be 606. And we have to find the what fractional increase in the tension of one wire. So fractional increase in tension is given by delta T upon T, which we want to. Each wire is vibrating in its fundamental mode, and its frequency is given by F equal to velocity upon wavelength, where velocity of string is equal to under root of tension divided by mu, where T is the tension of string and mu is the linear mass density. Now let us suppose that the frequency in first wire is F1, which is equal to this, we will replace velocity with this, then this is equal to 1 upon lambda T upon mu, and frequency of second wire is F2, which is equal to 1 upon lambda T plus delta T upon mu, because linear mass density is constant, but there is a slightly change in tension. So now this is equation number 1, this is equation number 2. Divide 2 by 1, then we will get F2 upon F1 is equal to, they both will cancel out, so we will get T plus delta T upon mu divided by T upon mu. Mu will cancel out, so we have T plus delta T divided by T, or T divided by T plus delta T divided by delta T. So F2 upon F1 is equal to 1 plus delta T upon T, and we want to find this T delta T divided by T, because we want to find the fractional increase in the tension. So we will square root on both sides, then we will get F1 F2 upon F1 whole square equal to 1 plus delta T upon T, or delta T upon T is equal to F2 upon F1 whole square minus 1, and we know the value of F2, which is 606 divided by 600 and minus 1. So this is square, so 606 divided by 600 is equal to 1.01 whole square minus 1, delta T upon T is equal to 1.0201 minus 1, and this is equal to 0.0201. So delta T upon T is equal to 0.02. So this is the frictional increase in the tension of second wire. So this is the answer.